In this video, I'm going to show you how to integrate some of the functions using the techniques of integration by parts. So many of the functions we can only integrate using these techniques. So in integration, this is one thing you should know. So the formula of integration by parts is derived from the product rule of derivatives. So as you remember, in differential, the product rule of derivatives, if we're going to differentiate a function u, v, it is equal to the first function times the derivatives of the second function plus the second function which is v times the derivatives of the first function which is du. And then as you can see, if this is our now differential function, as it is the answer of the derivatives, therefore if we're going to integrate this function, it is going to equal to the original function. So therefore we can have this equation: the integral of u dv plus the integral of v du is equal now to uv. Then by transposing this function to the right, so we have the integral of u dv is equal to uv minus the integral of v du. And this is the formula for the integration by parts. Integration by parts. So therefore, to prove that this formula is applicable in any functions, if we're going to integrate the function x dx, so using the power formula of integration, so it is equal to x squared over 2 plus an arbitrary constant. So therefore, by using this formula, the formula of integration by parts, by letting our u is equal to x and dv is equal to dx, so our du is equal to dx, and then finding our v is equal to the integral of dx, which is x. So therefore, by integrating x dx using the integration by parts, we have u times v, where our u is equal to x and our v is equal to x. Therefore, we have here x squared minus the integral of v du, which is our v is x and our du is dx. So therefore, in simplifying, we have x squared minus the integral of x dx is simply x squared over 2 plus an arbitrary constant. This is c. So therefore, 1 minus 1/2 is simply equal to 1/2 of x squared plus an arbitrary constant, which is equal to the answer using the power formula of integration. So therefore, this formula is really applicable in any functions. But there are some functions that you can only integrate using this formula or using this technique. So let's take another example. So for example, if we're going to integrate the function x e or exponential raised to x dx, so as you can see here, you cannot use the du and du representation substitution here, because if we let u as our x, therefore the du is equal to dx, which is, we cannot cancel out this function. So therefore, the only thing we can use to integrate this function is by integration by parts, whereas the formula is u dv is equal to uv minus the integral of v du. So the first step in integration by parts is by finding your u and your dv. So as you can see here in this function, we have the product of the algebraic function. This is algebraic function and the exponential function. And if we're going to integrate in this kind of function, what we're going to represent as our u is the algebraic function. So therefore, our u here is equal to x. And then dv here is the remaining function, which is a to the x dx. So by finding our du is equal to dx and v is equal to the integral of ax dx, which is equal to ax. So therefore, by substituting this formula, so the integral of x ax dx is equal to u times v, where our u is x and our v is e to the x minus the integral of v du, which is our v is e to the x and our du here is equal to dx. So now as you can see, we can easily now simplify this function. So we have x e to the x minus the integral of ax dx is simply ax plus an arbitrary constant. So therefore, this is our final answer. So next example, how about we're going to integrate the function of x squared times a to the negative x dx. So I said, if you're going to integrate the product of algebraic function and the exponential function, what you're going to represent here as your u is the algebraic function. So your u here is equal to x squared. Then by finding the du is simply equal to 2x dx. Then your dv here is equal to the rest of the function, which is a to the negative x dx. Then by finding your v is equal to the integral of a to the negative x dx, which is equal to a to the negative x over negative 1, simply equal to negative a to the negative x. So by substituting the formula of integration by parts, so we have u v minus integral of v du, because this is the integral of u dv. This is your u and this is your dv, and it is equal to uv minus integral of v du. So therefore, your u is equal to x squared and v is equal to this function. So by multiplying, so we have x squared times negative a to the negative x, then minus the integral of v du. So you have here v negative a to negative x. Your du is equal to 2x dx. So in simplifying, you have here negative a to x times x squared minus, then you have minus here, so you have here plus the integral of a to the negative x 2x dx. So as you can see here, we cannot easily integrate this function, so we're gonna use integration by parts twice here. So in this function, we also represent our u is equal to 2x, then the rest function is our dv, which is equal to a to the negative x dx. So your du here is equal to 2 dx. And then your v is equal to negative a to the negative x by integrating this function. So therefore, in simplifying, so we have here, let's go down, it is equal to negative x squared a to the negative x, this one, plus here we gonna use u, also this formula. So we have u times v. So we have now u, which is 2x, times our v, which is minus a to negative x, then minus the integral of v du, which is your v is this function. So we have minus a to the ax, then your du is equal to 2 dx. So therefore, in simplifying, you have here so in these two functions, so by simplifying, you have here negative x squared a to the negative x plus 2x times minus a to the negative x. Then we have here negative sign, then 2, so we have here plus 2 integral of a to the negative x dx. So in simplifying, we have here 2, the integral of a to the negative x is simply a to the negative x over negative 1, then add c. So in this function, so we have here minus 2x a to the negative x, then a to the negative x squared. So therefore, in simplifying, we have the common factor here, so we have a to the negative x times, in this term we have here minus x squared, then in this term we have minus 2x, then in this term we have 2 divided by negative 1, which is negative 2, then plus c. So that is our final answer. So next example, how about if we're going to integrate the function of y times cosine of 4y. dy. So as you can see in this function, we have the product of an algebraic function and trigonometric function. So in this kind of function, what you're going to represent here as u is also an algebraic function. So therefore, by representing u is equal to y, your du becomes also dy, and the rest function is equal to dv, which is equal to cosine of 4y dy. Then your v is equal to the integral of this dv, which is cosine of 4y dy. So therefore, it is equal to the integral of cosine 4y is simply sine of 4y over 4. So therefore, by the formula of integration by parts, we have uv minus the integral of v du, because this is your u and this is your v, your dv. So therefore, u times b, we have here our u is equal to y, and your v is equal to 1/4 of sine 4y, then minus the integral of v du, which is your v here is 1/4 sine of 4y, then your du is equal to dy. So therefore, by simplifying, we have 1/4 y times sine of 4y minus 1/4 times the integral of sine of 4y dy. So therefore, it is equal to 1/4 of y sine of 4y minus 1/4 then times the integral of this of sine of 4y is equal to the integral of sine is negative cosine of 4y over the derivatives of the inside function, which is 4. Then don't forget to add an arbitrary constant. So therefore, in simplifying, we have 1/4 here of y times sine of 4y. Then we have negative 1/4 inside and times the 1/4 outside. So we have positive 1 over 16 of cosine 4y. Then plus an arbitrary constant. So that is our final answer. Or by factoring, it has a common factor of 1/4. So it is equal to y sine of 4y plus 1/4 of cosine of 4y plus c. So that is your final answer. So last example, how about if we're going to integrate the function of x squared times the ln times the natural logarithm of x dx. So in this function, what you're going to represent here as u is the natural logarithm function, which is ln x. So by representing our u, which is equal to ln x, therefore the residual function is equal to dv, which is equal to x squared dx. So therefore, by finding our du, we have the derivatives of ln x is 1 over x dx, and by finding our v, which is the integral of this function, which is equal to 1/3 of x cubed. So therefore, if this is our u and this function is our dv, so therefore the integral of this function is equal to uv by integration by parts minus the integral of v du. Then by substituting our value, so we have now our u, which is equal to ln of x times our v, which is 1/3 of x cubed, then minus the integral of v du, which is our v is equal to x cubed over 3, and our du here is equal to 1 over x dx. So therefore in here we can cancel out 1x, so it's become 2. So therefore by simplifying, we have 1/3 of x cubed times ln of x minus the integral of, we have here 1/3, which is the constant. Then we have remaining after x squared dx. So in simplifying, we have 1/3 x cubed of ln x minus 1/3 times the integral of x squared is simply x cubed over 3, then add c. So by simplifying, we have 1/3 of x cubed times ln of x minus 1/3 times 1/3 inside, so we have 1 over 6 x cubed. It is 9, then add c. So that is our final answer.